Venus, the second planet from our sun. It shines like a brilliant jewel in our night sky. Sometimes we call it the morning star. Other times, it is the evening star. For centuries, humanity has gazed at its light. We have wondered about this bright neighbor. What mysteries does it conceal beneath its gleaming clouds? It beckons us with its ancient light, a silent invitation to explore. Venus is often called Earth's twin. This nickname comes from some striking similarities. Both Venus and Earth are rocky planets. They are nearly the same size. Earth is just a little bit larger. Their masses are also very close, and they are made of similar stuff, born from the same swirling disk of gas and dust that formed our solar system. They are cosmic siblings, sharing a common origin. But this twin label can be deceptive. If Earth is the gentle twin, Venus is the fiery one. It is a world of extremes. While Earth teems with life, Venus is a furnace. Its surface is hot enough to melt lead. Its atmosphere is a crushing, poisonous blanket. It is a vision of a paradise lost, or perhaps a paradise that never was. Venus shows us how differently sister worlds can evolve. So Venus presents us with a profound cosmic puzzle. It is so like Earth in some ways, yet so terrifyingly different in others. Studying Venus helps us understand our own planet better. It teaches us about the delicate balance required for life to flourish. It's a stark reminder of how planetary environments can change. The story of Venus is a critical chapter in our solar system's tale. Now, let's journey into Venus's atmosphere. Imagine an atmosphere so thick, so heavy. It presses down with enormous force. The pressure on the surface of Venus is over 90 times that of Earth's. This is like being nearly a kilometer deep in our oceans. This dense shroud is mostly carbon dioxide, a gas we know is very good at trapping heat. This is a key to understanding Venus. Venus is caught in a runaway greenhouse effect. This is why it's the hottest planet in our solar system, even hotter than Mercury, which is closer to the sun. Sunlight pierces the clouds and warms the ground. The ground tries to radiate this heat back to space, but the thick carbon dioxide atmosphere traps it. The heat builds up, creating an inferno, a powerful lesson for us on Earth. The clouds of Venus are not fluffy white water clouds. They are made of droplets of corrosive sulfuric acid. These thick yellowish clouds completely hide the surface from our view. They race around the planet at high speeds, creating a global weather system unlike anything on Earth. Imagine acid rain that never reaches the ground. It evaporates in the intense heat below, a truly alien sky. Below these clouds lies a tortured landscape. The surface temperature averages a staggering 465 degrees Celsius. That's about 870 degrees Fahrenheit. Hot enough to turn rocks into glowing embers. Vast volcanic plains stretch for thousands of kilometers, dotted with countless volcanoes, some of which might still be active. We see mountains, rift valleys, and relatively few impact craters. Its surface tells a story of fire and brimstone. Venus also has a peculiar way of spinning. It rotates incredibly slowly. One day on Venus, from one sunrise to the next, lasts for 243 Earth days. This is longer than its year. A Venusian year, the time it takes to orbit the Sun, is about 225 Earth days. So a single day on Venus is longer than its entire year. This is a very unusual rhythm in our solar system's dance. Even more strangely, Venus spins backwards, compared to most other planets, including Earth. This is called retrograde rotation. Most planets spin in the same direction that they orbit the Sun, counterclockwise if you look down from the Sun's North Pole. But Venus spins clockwise. So, if you could stand on Venus, the Sun would appear to rise in the west, and it would set in the east. A cosmic rebel. Humanity has sent robotic explorers to this hostile world. The Soviet Union's Venera program was pioneering. Their landers bravely plunged into the thick atmosphere. They were the first spacecraft to land on another planet, and they sent back the first images from Venus's surface. These heroic probes did not last long in the extreme conditions, but their data was invaluable. They gave us our first glimpse. NASA also contributed significantly to Venus exploration. The Magellan mission in the early 1990s was a game changer. It used powerful radar to pierce the thick clouds. Magellan mapped about 98% of the Venusian surface, revealing a world of volcanoes, lava flows, and complex terrain. Other missions like Pioneer Venus and Parker Solar Probe have also studied its atmosphere, its weak magnetic field, and its interaction with the solar wind. So, why does Venus continue to fascinate us? Why do we invest so much in studying this scorching world? Venus serves as a natural laboratory. It helps us understand how planetary climates work and how they can go terribly wrong. The extreme greenhouse effect on Venus is a stark warning. It shows what can happen when atmospheric composition changes dramatically. This knowledge is vital for understanding climate change on Earth. Venus also holds crucial clues about the formation and evolution of rocky planets. It forces us to ask, how did two planets born so similar in size and composition end up so dramatically different? What geological processes shaped Venus's surface? Are its volcanoes still erupting today, reshaping its landscape? Does it have a core like Earth's? The answers lie hidden beneath its clouds, waiting to be discovered. Its lack of plate tectonics is a major puzzle. The quest to understand Venus continues. Several new missions are on the horizon. NASA is developing Veritas and Da Vinci Plus. Veritas will create detailed three-dimensional global maps. It will help us understand Venus's geologic history. Da Vinci Plus will send a probe deep into the atmosphere. It will measure its composition precisely. The European Space Agency's Envision mission will also provide comprehensive observations. These missions promise a new era of Venus exploration. What secrets might these future missions unveil? Perhaps they will find evidence of ancient oceans, or clues to how Venus lost its water if it ever had any. Some scientists even speculate about the possibility of microbial life, not on the surface but high in the cooler cloud layers. It's a long shot, but science thrives on asking bold questions. Venus remains a captivating enigma, a reminder of the incredible diversity of worlds. Its story is far from over.